Evaporation can be estimated using empirical formulas, one of which is Meyer's. Check how to compute using his formula here in hydrology. So what is Meyer's formula for evaporation? E sub L is the daily evaporation in millimeters per day, and the first coefficient in the expression is K sub m, which stands for a constant taken as 0.36 if the catchment is deep, or take 0.5 if it is shallow. The next quantity is E sub W and E sub A, both of which are vapor pressures expressed in millimeters of mercury. E sub W is the vapor pressure of the water surface, and E sub A is the vapor pressure of air. These two are interconnected as air surrounds water. The last term includes U sub 9. This is the wind velocity measured 9 meters above the ground. Let's solve a problem showing the procedure in using Meyer's equation. It states that a record on a reservoir was provided, stating the temperature of water surface as 25 degrees Celsius, the relative humidity is 60%, and wind velocity is 10 kph, taken 2 meters above the ground. We have only one formula from Meyer, and to identify the coefficient K sub m, we check that the area is a reservoir, thereby concluding this can be a deep water basin. Thus, we use 0.36. The next to consider are the two vapor pressures. The first is the saturated vapor pressure taken at the water surface. An additional formula is necessary, that is E sub W as equated to 4.584 multiplied by the Euler's number raised to 17.27 T upon 237.3 plus T, where T is the temperature on water surface. The problem states that the temperature at water surface is 25 degrees. So plugging this value into the exponent, we get 4.584 E raised to 431.75 upon 262.5, which is simplified as 1.6448, making the water vapor pressure equal to 23.745 with the unit of millimeters of mercury. For the air vapor pressure, E sub A, this is computed as the fraction of the water vapor pressure. The fraction is relative humidity. So E sub A is 23.745 multiplied by 0.60, which makes 14.247 millimeters of mercury. The other parameter to figure out is U sub 9, or the wind velocity. From the formula, this has its name because the wind velocity is measured 9 meters from the ground. But the wind velocity in the example was measured at just 2 meters distance, which means we need to convert it to the standard. The wind velocity uses the 1/7 power rule, which means U sub h is a constant c times the height raised to 1/7. To convert wind velocity, take the ratio of the standard and the actual, that is U sub 9 over U sub 2. So if we convert them into heights, we have the ratio of c times 9 raised to 1/7 with c multiplied by 2 raised to 1/7, where we can cancel c's, then cross-multiply U sub 2 to get the function for the standard U sub 9 as U sub 2 times 9 raised to 1/7 over 2 raised to 1/7. If we plug in U sub 2 of 10 kph, U sub 9 is then computed as 12.397 kph. Having figured out all the necessary parameters, All we needed to do is to place them into Meyer's formula to have the daily evaporation E sub L. So K sub M is 0.36 multiplied by E sub W of 23.745 minus E sub A of 14.247. Then multiply 1 plus 12.397 over 16. Then we get the daily evaporation rate of 6.0686 with the units of millimeters per day.